All right, so we're live. Anyway, what's up? How are you?
Yeah, I'm okay. I just had the most vivid sexual experience while you were gone, girl.
That's amazing.
I know it is. It was bliss. I want to try evolve my sexual appetite for.
That's amazing. One second. Let me just the previous video, did you hear it?
I wasn't able. I was actually in a meeting and I was at work.
Oh, okay.
Yeah.
So what did we discuss? I think we started discussing waves
Yeah.
and a little bit of Galileo, my what could have been Galileo's theory.
Galileo Galilei.
Yeah, theory of gravity based on Galileo. Theory of gravity. Shut up, Siri. Theory of gravity based on Galileo, and then we did Newtonian Newton's. What did we do? Newton's. Do you remember what we did? Newton. We developed.
The first, second law.
Right, Newton's laws. That's true. But also, we did. We showed that his gravity is not a force because it's independent of the test mass, Newton laws, and mass
We
invariance.
we also covered Einstein's equivalent law.
I didn't talk about Einstein in this video. I just showed that there is a Galilean equivalence principle. So I guess on Galileo's equivalence principle, no one has these terms. These are like terms that we've invented. So
Oh,
okay, but if you look at Galileo's equivalence principle, I don't think you'll see anything. I don't think anyone has that. Anyway, so do you want to? So let me. Did you see what I wrote? Like
yeah.
late earlier today? You didn't see it. Anyway, so today I was thinking about quantum mechanics.
Oh yeah. Okay, okay.
So I have a feeling of where particle duality comes from because particle duality, I'm beginning to become convinced. Well, you don't know what particle wave duality is. Let's
It's
ignore
like
it.
something's a wave or it says something else. I think.
Yeah, like we don't know. Like every particle, we don't know if it really is it a particle or a wave because everything behaves sometimes like a particle and sometimes like a wave. It's like the weirdest thing. We're just unable. We have not been able to figure out what's going on because a thing could be both a particle and a wave simultaneously. It's driving everyone insane. But
Wow.
it actually comes out of GR. If you think about a theory of gravity, you will see that the particle wave duality comes out of that without any experiment. So so Galileo could have predicted particle wave duality.
How can something be a wave and a particle at the same time?
That's really weird. I know that's really bizarre, but that is the fact of the matter. I don't know how. I don't know, but and it violates my premise that we cannot state things that we don't understand. But but it comes out of general relativity. It comes out. It comes out. I mean, it comes out of Galilean rivet. If you develop Galileo's theory of gravity, you will see that it comes out of that. It comes out of the fact that space flows. Once you say that space flowing through you is the force of gravity, that is gravity, then then that means right now space is flowing through you. That means that when you fall, you're falling with space. Your space is causing you to accelerate. Um, so a planet like the moon right now, the moon doesn't feel like it's accelerating. The moon is in free fall. If you so the moon is right now embedded in space. So the moon is not moving in space. Once you start moving in space, my intuition is once you start moving in space, you can only do that as a wave. You cannot move as a particle.
Uh-huh.
You can say, like, one of the ways you can say that, one of the places where it comes from is the, the maximum, the speed limit of light. So Einstein said that you cannot move faster than light.
Yep.
Why not? Why can't you move faster than light?
It violates, was it conservation laws or something? It violates some sort of law in physics, but I forgot which law that is.
So actually, Einstein never said that. I mean, of course, you can move faster than light. You can move, right? Motion,
It's if you have mass. You can't do it if you have mass
right?
because you violate some.
But first, let's state it correctly. So, of course, you can move at the speed of light. You can move at a trillion times the speed of light. You can move at a trillion times the speed of light. Why can you do that? How do I know that you can do it?
Uh,
Let's prove it from first principles. So if you are, let's empty the universe of everything, and let's put you alone in the universe, in a spacesuit.
uh-huh.
How fast are you traveling? Does that have a meaning?
No,
No.
there's no
So
reference. No
there's no,
reference point.
right. So there's no meaning to say that you can travel at the speed of light, at a trillion times the speed of light. There's no meaning to saying that you're stationary. It doesn't mean anything. So speed doesn't mean anything. You always have to say relative to. Relative to means
Yeah.
you're observing something. Relative to something that you're observing. So so you cannot move faster than light, meaning you cannot observe anything moving faster than light. I mean, and that should be obvious because the only way you can observe is using light. How else would you observe?
Hmm.
Okay, so the speed of observation is limited to the speed of light. Let me ask you a question. What determines the speed of light? Why, right? The speed of light, they've measured it. It's some constant. It's very slow. If you talk about astronomical distances, the speed of light is excruciatingly slow. Like, they just discovered two black holes that collided a billion light years away. That means a billion light years, two black holes collided, and just now, a billion years ago. Do you know what that
Hmm.
is? That's like before there was life on Earth was single celled. We've only become multicellular, I think, just in the last billion years, or even half a billion years.
Oh.
So a billion years ago, two black holes collided somewhere, and just now the gravitational waves arrived at Earth, which travel at the speed of light. So light travels relatively very slow compared to the vastness of the universe. Anyway, what determines the speed of light? Why is the speed of light whatever it is? What causes the speed of light? What causes this 300 million meters per second to be the speed of light? What causes it?
Laws of physics. Like, how would you respond to that? Like, that's just how things are.
Right, but we can this look. We can always try and peel the layers of the onion of reality one at least one peel at a time and try to answer what causes a phenomenon. Right? You notice a phenomenon and you want to be able to answer mechanically what could cause it. So
Okay.
what could cause a speed limit? One second. Okay. So what could cause the speed limit of light? Not only is there a speed limit, it's the limit above and below. Light always travels at the same speed. It's not like you can send a light whatever light ray at slowly faster, but you're limited by the speed of light. You're not limited by the speed of light from below. You're also limited from above. It's always the same. It's not slower. It's not faster. It's exactly that always. It's not like a particle that you can send it off at different speeds. Light always travels only at light speed. Why is that? Why is speed of light
Oh,
constant?
it just maybe okay. Uh, I mean, intuitively, I want to say that that's because everything is designed a certain way. That's what I want to say.
You could say
Like,
that,
I don't.
but saying things are so because the things are so, that's not an answer. That's nothing. You didn't answer. You're not adding information to the conversation.
It's kind of like if we play like a this game where everything needs to be explained, it seems like nothing actually will get explained.
But that is science. In science, we try to answer why are things right. We notice the phenomenon and we cannot explain it, and we would like to offer a mechanical, simple, deterministic explanation to to this phenomena that we have noticed, and that is going to be our scientific theory. And from that, we're going to make a prediction, and then we'll test the prediction, and we'll compare the prediction to the actual result, and we'll validate the theory or reject the theory. That is how I see the scientific method.
Okay. So let's try to play this game of explaining. Maybe the idea is that if things could travel faster than light, uh, well, I want to say that it's gonna. Well, I hope this is not too science fiction. It's gonna like have trouble with time and space, like it's gonna time travel or something like that.
But
And
I'm looking for a mechanical explanation. Every explanation that's going back to my proposition 90, every explanation must be mechanical. You have to be able to build a mechanical explanation, and that must be your theory. Your theory must be a mechanical explanation, a mechanical contraption.
by mechanical, you just mean from first principles.
Whatever explanation you have, like um, you're asking why why is my computer not working? Oh, because I didn't plug it into the electric socket. Right? It's a mechanical explanation. My tooth is hurting. Oh, because certain creatures dug holes into my tooth. Okay, that's a mechanical explanation.
So
Um,
you want me to give
what?
like a because of, you want me to give a because
Because
of
has to be,
why.
but it has to be mechanical. So you could say, I'm hungry. Why am I hungry? Oh, because I didn't eat, right? Eating is a mechanical explanation of hunger. I'm full. Oh, why am I full? Oh, because I ate too much. My leg is broken. Wait, why is my leg broken? Oh, because I kicked someone and my shin hit their knee. So my shin broke. I mhm. So I want a mechanical explanation. Why does the speed of light exist to begin with?
mm, you tell me. I don't know. I think the best explanation is things were designed that way by
By the
God or
gods.
something.
Yeah. But God God is not a mechanical explanation. So God cannot be a scientific theory.
What do you mean by mechanical then? Like, if you defined it, how would you define it?
You can build a 3D model. You can build you can build it. You can build
What do you mean? 3D
build
model.
you can build a model. 3D just means like a contraption. You can build it. You can build it and show how it works.
Okay, so God designed everything, and I'm building the model. So the model is going to predict that
But God
anything in this cell,
but God is not a mechanical contraption, so that's no good.
it's got predictive power.
Yeah, but it's not mechanical. It's gotta have predictive powers, but it's gotta be mechanical. I need to see a mechanical model to explain the phenomenon. Otherwise, I don't understand it. The purpose of the purpose of science, the scientific method, is to understand the universe. So if you're going to give me an explanation that doesn't make me understand the universe, then it's useless. So what's the point? Oh, you're telling me, well, there is a confusing explanation. Well, then I'm not interested. I'm interested in a simple explanation, not in a confusing. I don't want to be confused.
Oh, that that seems like a very simple explanation. God did it.
It's not mechanical. God is not a
The
mechanical.
fact, like, given a like mechanical.
I
Okay,
gave you
so
I gave you
it doesn't
examples.
mean predictive.
Like I gave you
But
examples. Like my stomach is full because I overate. Eating is a mechanical. It's mechanical. You right? I can show you here. Your stomach is like a bag. Your stomach is a bag, but let's say your stomach is like a bag. Let's fill it up with food, and I would pour in, let's say, water, and then it would be full, and it would explode, and that's how you feel. You feel like you want to explode because your stomach is like a bucket. Your stomach is like a bag, or like a plastic bag. It fills and fills and fills until it
what?
explodes. What?
Yeah, no, it's funny. Okay, opening the black box. I'm just trying to get my head around what's being what you're trying to get at by mechanical explanation. I'm not trying to be hard. I'm just it's not registering what's actually being talked about with mechanical explanation.
Okay, I'll give.
So I'm
Let me give
googling
you.
stuff.
I'll give you a different question. So the speed of sound is 300 meters per second. Why is the speed of
Okay.
sound 300 meters per second? It's always 300 meters per second. It's no less, no more. You cannot speak and have the sound travel slower than that or faster than that. It's always that. Why is that? What determines the speed of sound in air to be 300 meters per second? What causes that?
I mean, we've invented the term speed of sound, and whatever meets that meters per second, that's what the speed of sound is. Like, why does a triangle have three sides? That's just what a triangle is. That's just what it means to say
No, but
to speak of a triangle.
I'm looking for a mechanical explanation why the speed of light is 300. What determines the speed of sound? Why does sound have a speed to begin with? What determines the speed of sound?
Reality,
What?
reality determines it.
But reality is not a mechanical explanation where I cannot do
I
anything.
know, I know, I know. Okay, but like, I don't. For me, not everything needs explanations. I think
But But when
Right.
you do, so a proposition 90 is the proposition to make every discussion fruitful. If you don't follow proposition 90, then we'll end up exactly where we ended up with Mandible. It was an unfruitful discussion. The reason it was unfruitful is because his claim was that the universe cannot be understood. And what I realized is that I need to make a proposition that your proposition must assume that the world can be understood. Your proposition must be understandable. If you claim your proposition is not understandable, that's a conversation ender. There's nothing that I can do with that proposition. So part of being an understandable theory, part of that is it's got to be mechanical. I need to be able to reproduce it. I need to be able to build a model that explains that displays the phenomenon, that explains the phenomenon, that simplifies the phenomenon. So right, so I'm full. Why do I feel like my stomach is about to explode? Well, because your stomach is like a bag. Let's take a bag, and you ate or you drank so much. Let's fill it up with water or something, and we'll see that it overflows, and it breaks. It explodes. Why does it explode? Well, that's obvious. But now we have a mechanical contraption that models my stomach and it explains my stomach hurts.
You want something to account for why light travels at this speed.
Yes, but let's start with sound. Sound is simpler.
Okay.
We'll start with sound, or if you want, even with something simpler, like water waves. So we can start with water waves or whatever you want, but something simple. Then we'll go to light. We'll explain why light has that speed. It's not a speed limit, it's that speed. Why light speed is always a constant. It's not less, it's not more, it's exactly that always. Why? Why is the speed of sound exactly that always? Not less, not more. It's not like a particle that you can throw at different speeds. So, what do you think determines the speed of sound? What is sound? Do you know what sound is?
It's like it's the vibrations in the air
Very good.
which enter eardrums,
Right.
and
But
your
what is.
brain registers it as whatever it registers it as.
Wait, I didn't hear anything. You were touching your mic.
Okay. Oh, okay. So it's vibrations in the air. It's gonna enter your. It's gonna enter the neurons, and it's gonna register these vibrations in a certain way. That's why there's different
Well,
sounds.
that's already you're involving the neurons. Let's ignore the neurons. Let's just talk about what is sound. So you're saying sound is the vibrations in the air. Okay.
Uh huh.
So let's have, for example, we can have one of those. Oh, one second. One of those forks. You know that they use in science class, right? There is this
Oh,
fork on a like on like a box, and the teacher they smack they smack the fork. They smack it, and then wait, the color is terrible. They smack the fork, and the fork starts sounding some noise. Some noise starts coming. Oh, you weren't watching?
I was trying to find it. I was gonna ask like how you are showing this, and now I've suddenly found it. So,
You can maybe the easiest thing is to just go watch my YouTube stream so you can see
oh, is that
what?
Okay. Yeah. 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 That's a better idea. Yeah.
Yeah, you can watch it. If you want to draw, you can come here to draw. But if you want to just watch, I think the best is to watch the stream. Je stream.
Yeah. That's
You will eat the
okay. That's
bugs. You eat the bugs. All right. So you smack it where the arrow is, and then it starts making noise. The whole class can hear it humming, zzz, and then slowly it fades away. And by the way, if the teacher puts another fork over here, then do you remember what happens? Anyway,
no.
when the teacher smacks the left fork, you can actually
Uh-huh.
see it shaking. You can see
Yeah.
the
Vibrating. Yeah.
yeah, you can see it vibrating. It vibrates, but then you can suddenly see that this one also starts vibrating. Uh,
Uh-huh.
do you remember that?
Yeah.
So how does that work?
Well, the vibrations, they're like, hmm.
Yeah,
I don't know. It's like tiny like things in the air
right.
cause
Exactly,
which cause like objects to like pick it up. That's the
exactly.
best I can.
So the air is composed of tiny things that we call air molecules. And these air molecules basically are touching each other. They're bouncing against each other. They're always bouncing against each other. And actually, the speed at which they bounce against each other is determined by the pressure of the air, the temperature of the air, the humidity, maybe other things. I don't know. All right. So what happens when the fork on the left vibrates? It moves, right. This one, it moves. Sometimes it's here, and then sometimes it's here, and sometimes it's in the middle. It keeps moving
Uh-huh.
back and forth really really fast, but it's moving back and forth. It's moving to the left, to the right, to the left and the right, to the left and the right. So when it moves to the right, it's it's hitting air molecules, and when it's moving to the left, it's basically, you could say, it's sucking them in. It pushes them to the right when it moves to the right, and it pulls them to the left. It sucks them to the left when it moves to the left. It moves to the right and pushes them to the right, and then it moves to the left. It sucks them to the left.
Hmm.
So you could say, but it does it to all these molecules at once. The molecules that are touching it are all impacted by this motion at once.
Could
So
you describe it as like a field? It's like a field, and all the air molecules
you could
they're being
call
attracted, like
you can
bouncing off of each other and stuff.
a field is like a little bit of more of a fancy word in physics. It's
Oh, okay.
yeah, usually you want to stay away from fancy schmancy words that people are not
Yeah.
going to understand. It's a field. Maybe later we'll need it. Anywho, so the fork. So there is a bunch of molecules right next to it, and basically the fork smacks them and retracts, smacks them and retracts. Okay, smacks them. So when the fork smacks this guy, well, this guy is a real thing. It flies off to the right, and at the same time, this guy is also smacked, and this guy is also smacked and flies off to the right. They all fly off to the right all at once, and then they end up here. But here, there was another molecule. So this guy moved from here to here, and he smacked against a molecule. Well, guess what? This molecule is now going to fly to the right until it smacks against another molecule. And
Hmm.
this one is going to run to the right and smack against another molecule. So you could
Okay. Yeah.
right. So you could say that virtually there is like a bunch of molecules approximately here and approximately here. And you can imagine that, right? These guys get smacked, and these guys get smacked, and these guys get smacked, and this is beginning to look like a wave. So you could say that basically the fork, by moving back and forth, is every time it moves to the right, it's moving a wave of air molecules to the right, which causes this line of molecules to push the next line of molecules. So you could say that there's a propagation of a wave towards the right. It looks like something is moving to the right. But let me ask you, are the air molecules moving to the right? I mean, we can say that there is a propagation of something to the right, but would you say that the air is moving to the right?
Mm. Uh, I guess sometimes when they bounce off of each other, they're gonna be moving to the right.
Right.
But you can also say that maybe it's just a fork which is moving to the right, so it's making it look like the air molecules are.
Wait, no, this guy had to move to the right to move to hit this guy, which had to move to the right to hit this guy, which had to move to the right to hit this guy. So they have to move to the right. But then the fork moved to the left. So it caused like a suction. And it actually caused this guy to move to the left.
Oh, I see. Okay, okay.
So on
It's,
average, mhm.
no, no, go on, go on.
So on average, this molecule moved to the right and then to the left, just like the fork. Just like the fork was moving to the right, or is moving to the right and to the left, the fork is shaking to the right, to the left, to the right, to the left, and it causes the air molecules to also vibrate, move to the right, move to the left, move to the right, move to the left. Well, this happens to this line of molecules, but then this this pattern is transferred to the next line of molecules, which also move to the right, to the left, to the right, to the left. And this keeps going and keeps going. So a molecule kind of far away, like on the other side of the room, is also moving to the left and to the right, to the left, to the right. Well, so these waves of energy, propagation of energy, propagation of something, this propagation ends up at one point smacking against the fork on the right. And as all these molecules smack against the fork on the fork on the right vibrates and moves to the right and moves to the left. So this fork ends up moving to the right, to the left, to the right, to the left, just like the original fork. What do you think?
Yeah, I'm following. Yeah.
That's good. Now this fork on the right, that could also be your ear and your eardrum. And your eardrum, like you said, right? There's an ear, and there's a hole in the ear, and then there's an eardrum, and the eardrum is very sensitive. It's a very thin membrane. It's a very thin, like a rubber, mm, like a fabric, like basically like the drums of a drummer. But it's like a drum, and these vibrations moving back and forth, they hit it, and they actually cause the eardrum to move to the right and to the left, and then this gets transferred somehow into a liquid in the inside the ear, and that liquid moves hairs inside that liquid, and those hairs are connected to actual neurons that convert it into an electric signal, and from there it gets everywhere it needs to, and then you
Interesting.
perceive the sound.
Okay.
Okay, but we're not going to talk about what happens in the head of an animal or a human. That's for a different day. All right. Now these waves. So when a molecule when the fork hits a molecule, it hits all these a wall of molecules all at once. So we can call this a pressure wave. We can call each one of these things a pressure wave. Why is it a pressure wave? Because what is pressure? Pressure is if there is many molecules forced to live together, they're under pressure. If there
Mm-hmm.
is if there is like very few molecules and we're trying to suck them apart, then it's low pressure. So if we push many molecules to live together, we're saying we're increasing the pressure. And if we somehow like if I have like a box and I pull it apart and I create a vacuum, then inside I drop the pressure. And if I
So just
mhm,
to make sure I get it,
yeah,
a solid object, a solid object is going to have more pressure because there's going to be the atoms are going to be a lot more compressed in comparison to liquid.
I don't think
The atoms in
I don't think we define pressure. You can define pressure, but I don't think there's but we define that a solid is under pressure. We don't say that a solid is under pressure, even though it looks
yeah, it did
condensed.
sound a bit weird. Yeah,
Yeah,
it did
and
sound a bit weird.
you can put a solid object under pressure and compress it, and it will lose its shape or it will break, and that's what we do.
So
Hmm.
pressure is going to be when you take an object and you compress it against its nature. Like a spring, it's normally naturally it's going to be like pretty loose, and then you're going to compress it against its nature, so against how it was before. You're forcing it to.
But we don't say that a spring can experience pressure. Experience can A spring can experience force. It doesn't experience pressure. The definition of pressure actually has a definition. Let me just move this up a bit. Pressure is actually defined very precisely as force divided by area. So if you apply a force over an area, that's pressure. So
Oh, okay. So I get my finger, and my finger, my index finger, the surface area of my, the tip of my index finger, and I push down on your, I don't know, the table. So I'm applying pressure on the table.
right. So I would say like this. This is your skin, and here is a needle. So a needle can easily pierce your skin because you're applying a little bit of pressure. Let's say you're applying 1 gram of pressure, or let's say 10 grams of pressure, but the area is tiny. It's over 1 millimeter squared. So 1 gram of a 1 millimeter squared is actually very high pressure. And that's why you break the skin. Now, instead of 10 grams, you can put 10 kilograms, but on, let's say, 10 centimeters or even 1 centimeter squared, and it's not going to hurt. Right? You can hold a 10 kilo on 1 centimeter of your skin, it's not going to pierce it. But even though the 10 kilo, the force is much bigger, even though 10 kilo is not a force, but let's imagine 10 kilo, you can say 10 newtons instead of, I think they interchangeably we say newtons and kilos. Newton at surface level, a kilo at surface level weighs a newton. It's the same. So, so the pressure of right. So this pressure is actually much lower than this pressure. This pressure, even though it's just 10 grams of pressure, but because it's just over, it's not even 1 millimeter. It's probably 1/10 of a millimeter squared. Even 1 millimeter, you wouldn't pierce the skin.
So it's because it has less area, but it's more impressive.
Exactly, exactly. The,
Very
the
very
area,
good.
so that's the definition of pressure. So going back just to the box, so like if you have, what do you call it, when the doctor injects something like medication, what do you call it? Like the schmaxine. So there's a needle here, and there and and there's,
Vaccinate.
yeah. Don't say that word because we YouTube will ban us. The crazies at YouTube will ban us. Will get insta banned. So just say schmaxinate and schmaxine.
Wait. Just keep it brief. But why? Like, what's the policy?
What's the
Why?
policy? YouTube doesn't tell you. The policy is go f go f yourself. That's what YouTube says is the policy. If you ask them,
Right.
so that's the policy is that you're poor, so go f yourself, or you're right wing, so go f yourself. That's the policy.
Right.
The policy is we vote for left. If you don't vote, if you're not left of Marx, of the worst
Oh,
communists, so we don't want your kind here. That's the policy.
interesting. Interesting.
Anyway, so what do you call it when the doctor injects you? What do you call this thing?
It's vaccinate.
No, but what do you call? What is this? It's in
Needle.
that's the
Injection.
that's the needle. What do you call the apparatus? The entire apparatus. What's the name?
What apparatus?
The apparatus, but that I drew here. What do you call it?
I can't. The drawing is bad, I guess.
No,
Oh,
like
is that the end of the needle?
the end of the needle is here. On the right is the needle. And here is the schmaxine, and they're going to inject you with schmaxine. With what?
Yeah. What are they going to inject you with?
With a schmaxine.
Sorry.
Okay,
Yeah. There's like a serum inside, and they
it's a
insert this
schmaxine, but
serum.
what do you call the apparatus? What is the
It's a
app?
needle.
No, it's not. The needle is just a tip. What is the apparatus used to inject and schmaxine?
Oh my god! Yeah, it's not even like that's not material. Let's just get on with it. I don't know.
Yeah, it's a
I don't know.
schmaxine.
Like nobody uses the term like what it's actually called. People call it a needle.
They call it needle?
Yeah.
I cannot accept that. That's like, it's not. It's not a needle. It's something else. Um, it's called a needle? That's the wrong name. It's not.
So I hate. Oh,
Well,
injections. Like,
they call it an injection. It's not an injection.
I know. Uh, I don't know. Like you go and tell me.
Maybe an injector. Maybe we can call it an injector.
Yeah, but that's like not an official name. That's just we
Intramuscular.
just made it up.
It's ordinary. Oh, they do call it a needle.
Oh my god! Yes.
This is
Yes.
terrible. Absolutely atrocious that they call it such a bizarre name. The needle is just a tiny part of it. Anyway, so they say fill up the needle with schmaxine? Yeah, why don't you fill it up with schmaxine? The what? The needle? No. Don't fill up the needle.
Uh,
The needle, you
hey,
need
let's
the whole
what is
thing needs
the
to be filled, not just the needle. Needle is not
no
enough.
the needle refers to the jabbing like the a syringe I guess no that's not what it is.
The syringe is the needle.
No it's not. The syringe is what you fill up with the liquid, the serum.
Really?
Yeah. This is like rejogging my memory. So yeah, this is a syringe, but nobody uses this term. It's like not outdated, but it's just people
How do
call
you
it a
spell
needle.
how do you spell syringe?
SYRINGE. Ringe. Yeah, it's a syringe. Yeah, I've heard it before. I guess that's the official term, but layman people you just call it a needle.
Hmm. Oh, okay. So there's this, okay, disposable syringe and needle. So we have a part called a plunger, a barrel, a needle adapter, a needle hub, the shaft, the bevel. Oh, that's the bevel. I'm learning so much now. Finally, I'm learning some words in English. Oh my God, this is the best day of my life since I discovered how to derive relativity from Galileo. Okay,
Since corn.
what?
Since we discovered corn.
Corn?
Yeah, corn.
Corn on a cob. Okay, copy image. Let me just share with you. At least since I suffered, you need to suffer too with this.
Uh-uh.
Oops. Wait. Here it is. Processing. Here is the image. Disposable syringe. These are the parts that make it up. Did you know that there is a needle adapter that holds the needle hub, that holds
Oh
the
my god.
shaft of the needle and the
Is this actually critical?
Oh yeah, we are. No, what I wanted to what I wanted to say is, right, if you when you let's say right, you remove the needle and put your finger, right, as children we used to play with it. So you remove the needle and you put your finger against the needle adapter and then you compress the air, right? Or you can suck the plunger out while your finger is on the needle adapter and you can create a vacuum in the in the
Mhm.
chamber. In the they don't say that this is the chamber, but this is the barrel chamber, whatever, right? So
Mhm.
if you create a vacuum here, it's called low pressure, and when you
Yeah.
push the plunger in and hold with your finger against, this becomes high pressure. All right. Anyway, so these are called the purpose of this discussion about pressure is we call these one second, we call these pressure waves. We call these
Okay.
pressure waves because when a bunch of molecules get together, that's high pressure, right? When let's say we have the plunger, this was intended to be the barrel, the chamber of the barrel. So if we pull the plunger away and hold our finger, then we have low pressure or a vacuum. That's when there's no molecules between two waves, like there's lack of molecules. And when we push the plunger in and hold with our finger, the pressure goes up, and that's when a bunch of molecules get together. So that's what happens when the fork moves to the right, it causes a bunch of molecules to get together because the molecules from before were here already, and now the fork moved to the right and pushed a bunch closer. So now there is a bunch of molecules together, closer together. That's high pressure. And where the fork moved away, moved to the right, it created an area of low pressure. But now this wall of high pressure is going to just cause is going to run to the right and smack against the next wall of molecules and create another region of high pressure, which, right, and in between the molecules went to the right, so they created a region of a vacuum. So there's a region of a vacuum and a region of pressure. So pressure, vacuum. So between any two pressures is a vacuum, and this wave travels. The wave moves to the right. That is what a wave is. What do you think of my explanation thus far?
Yeah, it's I follow,
That's good.
but I
Yeah,
would say so. Do you know deodorant sprays?
of course. I don't use
Yeah.
them. Yeah.
Well, I'm not. You don't use them.
No, I use solid,
You use what?
solid deodorant. I hate spray.
Oh, okay. Yeah. Well, deodorant may work off the principle of pressure. So you press you know, the nozzle or the lever, whatever,
Hmm.
and it's going to cause high pressure because it's compacting the gas molecules inside the chamber, and that's how it sprays out. But
Sure.
when you aren't pressing, it's going to be low pressure.
Yeah.
Okay,
No,
cool.
so the
Yeah, I
no, but
get it.
the pressure inside the container is high. When you press the nozzle, the pressure goes a little bit down, and then it
Oh,
remains.
okay.
Then you push it again, and the pressure goes down and down and down until the pressure goes to zero, and then it's like it's empty. But that's not. But those are not waves. What I want to discuss is what a wave is. This is actually called wave mechanics. So let's give it a name. This is wave mechanics. Wave mechanics. And you see the name is mechanics, just like I wanted our model of the speed of light to be. Right? So you already are beginning to see the hint that our model, this is going to be our model for the speed of light. Everything you're seeing now, this mechanical wave, we will also use this model for the speed of light, because this is the mechanical model. We understand sound mechanically. We have a mechanical model to explain the speed of sound. And now I'm going to present you with a mechanical model to explain the speed of light. But first, you want to try and explain this to me before we continue?
I think I kind of did with the deodorant bottle.
Let me just change the name of the video is what causes the speed of light to be constant. That's a good talk. That's a good
Okay.
title. Wait, I want you to explain to me how from the fork on the left, you get the fork on the right to vibrate. How does that happen?
So there's molecules in the air which are bouncing off of each other left to right.
Why
Uh,
why are they
and they're gonna,
why are they bouncing left to right?
so this fork,
Hmm.
this is moving left, and it's kind of, you could say they're hitting the molecules,
Hmm.
and the molecules travel through the air, and now it's at the second, what is it? The second fork, and essentially the same pattern is arising. So they're bouncing off of each other, hitting the fork, and the fork is moving as well.
Do me a favor. Go to the Discord image and explain it again, because I can't see your pointer.
Okay. You want me to
No, no,
explain
you
with?
can you can draw on top of my drawing. It's fine. But
I'll do it. Okay.
I want to make sure
Yeah.
that you understand this thoroughly.
Okay. I'm drawing underneath, or is
No,
that
no, you don't
should
have
I
to
draw
draw.
on top?
You don't have to draw. You can use my drawing, or you can draw.
Okay.
It's whatever you prefer. I would rather you explain it on my drawing, and then later we'll start again, and you draw from scratch again.
Okay. How am I?
Yeah, I see
It's
you.
not like.
I can see
Can
you.
you see? Okay. Well, do you see where the mouse is, or
Yes,
what?
yes. Everybody sees. The universe is seeing. Yes.
Okay. So the black fork on the left, So it's gonna be vibrating
Wait,
back and
let
forth,
me
back.
let me just stop you 1 second. So we have a comment from the emperor. He says, "Right, don't eat too much." Good point. Yeah, yeah. That's easier said than done. That's like if you think figuring out general relativity is difficult and quantum mechanics, not eating too much is by far the most difficult thing in the universe.
Uh,
What do you
no, it's
think?
not.
For you, it's easy.
No. Yeah. Like, don't be fat.
It's easy for you to not be fat.
Uh-huh.
Wow, you're lucky. For me, it's like
Yeah.
really hard. Like
Like,
I can become a balloon if I don't watch my weight.
well, you have to condition. You have to have discipline, I guess.
Exactly. Yeah, I need that. All right, let's go. Let. Okay, please explain.
Oh,
Um,
and wear a corset as well.
what?
So wear a corset.
That's a good idea.
Anyway,
I tried. I'm gonna. But if I wear a corset, that's not gonna help my to lose weight. Oh, you mean wear a corset to look thin?
yeah,
But you know why women wear corsets?
to look thin.
No, to reshape their body. A corset actually reshapes your body. It's like plastic surgery for free. If you wear a corset, it actually reorganizes your internals. It because your bones are plastic. If you can actually give yourself plastic surgery just by wearing a mask. It's just like an orthodontist, right? Right when he
Uh-huh.
straightens your teeth are embedded
Yeah.
in bone. So how can that work? So it's because the bone is plastic. You can, if you do it slowly enough, you can easily reshape any bone in the body. And that's how they make some people go through surgery to make your legs longer. You don't actually have to go through surgery. You can
Well,
just
interesting.
yeah, you can just
So
lengthen.
if I wear the corset, I can get a body like a girl.
Yeah, yeah,
Oh,
you can use a corset, but like if you have a girlfriend and you want to remold her, you could do that. You can give her, you can change her, you can give her a slimmer waist, and it's actually going to cause her to have wider hips.
how?
What?
How?
Because well, this like is it's like a different lecture. So
Yeah, no thanks.
when you press all the organs together,
Uh-huh.
where do you think they're gonna go? When you press the tummy tight, where do you think these organs? It's a right. Your tummy is a bag of organs. Where are these organs gonna go? If you press them hard, where are they gonna go? So
Okay, I see what you mean.
they're actually going to push against the the hips, the bones of the hips. There's like a cage. That's what protects the baby. That entire cage is under pressure now to grow. So the hips grow to the sides. So you can do amazing plastic surgery just by understanding, pressure and simple mechanics and understanding, basic concepts about the body. You can do miracles. If you have a bony nose, if you have a nose that is like the beak of a bird, you can straighten it without plastic surgery. If you do it slow enough, you could do it. If you want to have high cheeks, you can do it.
Expensive, bro.
No, it would be very cheap. You can
Sure.
reshape any organ in your body.
Well,
I'm amazed no one is doing it. I was gonna actually write a patent, but now I'm telling everyone. So I gave away my patent.
uh,
Let's go. So
interesting.
explain to
Yeah.
me, explícame the drawing. What are we looking at? What's going on here?
So on the left you have a tuning for. Sorry. Oh, that yeah, technically yeah. Okay. You have a fork.
Yeah, it's a tuning
Uh,
fork. This guy's a tuning fork.
yeah. And then you have these. It's like the U
But
shape.
you're not
These
you're not
prongs.
pointing. You use the pointer.
Oh, okay, okay. Can you see?
Yeah.
So the prongs, the two spikes in the U shape thing,
Hmm.
they're vibrating. They're like moving like rapid. They're moving very, very fast
Explain to me
and
how they're
vibrating.
moving. Can you explain to me how they're moving? Are they both moving to the left and to the right? Are they moving in and out? How do you think they're moving?
They move. Okay. Well, what the hell?
Do
How do I get
Control
this
Z.
out?
No, no, just do Control Z.
Oh no.
Do Control Z.
So
No, no, no. Control Z. Oh, you don't have a
um,
a keyboard?
no, I'm on my phone.
Oh, let me try and
Oh,
undo.
okay.
Oh, I can't. You can undo. There's an undo button on the.
Yeah, I just did it.
Okay.
Okay, so they're moving to and fro, back and forth, left and right, very, 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 very fast.
Okay.
And these molecules, they are following the same as the prongs, so they're moving back and forth, back and forth, back and forth,
Mhm.
and they're hitting off of these prongs as well, and they're traveling through the air, bouncing off of each other,
Wait.
up, down,
Explain.
up.
Point. You have to point as you're explaining.
Oh, okay. So you see these the molecules, all of these green dots. They're moving, traveling in the air, bouncing up and down, up, down, and they're traveling right.
Wait. What do
And
you mean?
now this,
Wait. What do you mean up down?
so they're moving through the air. So as they smash off each other, uh, it's not like they're following a certain path. Like, if you were like it's not like they're on a string. They're bouncing off of each other, and they're gonna be moving up and down
What? Why?
everywhere
Okay.
because they're smashing with each other. Uh, I don't know what to say. Like they're smashing off of each other and they're moving up and down, and they're also moving left and right.
Okay.
But because the tuning fork forced them to go to the right, that's the way they're going.
Okay.
This next tuning fork is actually like a kind of conductor. It's attracting. Making them move towards it because it's also vibrating as well. And now it's the prongs.
Okay.
Now the prongs are combining with the what do you call these materials in the air
The molecules.
molecules. Yeah,
Mhm.
I get the best explanation I can give. Maybe I've lost some stuff, the
Um.
value of a
Okay. I would. You know what I would. What I would say, even to simplify the explanation a little bit. Let me get rid of this. So I would say I would actually start with a pond. Let's look at a pond from the top. So here is a pond. We're looking at it from the top. And we're going to throw a rock, a pebble, in the center of the pond. And we're going to notice like waves coming out, like a circular wave pattern, right? Coming out from where we dropped the
yep.
rock, the pebble, right? Have you ever done that?
Yeah, I get it. Yeah, like a ripple in the air.
Like ripple, exactly.
Yeah,
It is a ripple. It's a surface. So these are called surface waves. So if we look at it from the side, so here is the lake. So we dropped the pebble here. So where we dropped the pebble, we caused the water to go down. 1 second. We caused the water level, let's do this. We caused the water level to go from here to here. Oops. It's to from here to here. So we
Wait,
created we
explain that again. From where to where?
so the water level was at the surface level, but then the pebble hit and the pebble pushed the water to this level. It pushed the water down.
Oh,
The water
okay,
has
yeah,
been
yeah.
pushed just a little bit down.
Down.
Yeah, the water level has been
Okay,
pushed a little bit
okay.
down where the rock. where the rock, right? The let's maybe make it a little bit bigger. So here's the water level, and here's the pebble. It's a bigger pebble this time. The pebble is causing the water level to go. Originally, it was here, and now the water level is basically here. So the water level, at least where the rock is, where the pebble is, has gone down this much. So we basically created a vacuum. We evacuated this region of water. There used to be water, and water is also, there's water molecules. Water is also composed of molecules, just like air.
Yep.
So there used to be molecules here, but we got rid of them because now the rock is there. The rock has displaced these water molecules. So they used to be where the rock is, but now they are somewhere else. Let's say we pushed them to be here and maybe a little bit here. They've been pushed aside. So we created a pressure region. This is now under pressure. Because the pebble is in the water, we created a pressure wave where there's extra molecules of water compared to where how many molecules were in this region before. The pebble pushed the molecules that were where the pebble is now, the pebble pushed them away. So now this area has extra molecules of water. And that's what we call a high pressure zone. One second, my Discord is resetting. I don't know why my Discord resets all the time. Does your Discord reset once in a while?
Nope.
Yeah. I hope it didn't erase the image. It is the image. Let's see.
Imago Day. Imago Day.
Imago Day? What's Imago Day?
Yeah. In God's image.
Fascinating.
It's still on my. Okay, no, it is.
Okay. So now we have a high pressure region, and again, right? Right now there is a high pressure. High pressure tends to go to low pressure. If you push something close together, and here, let's say here, any more colors? All the colors are basically the same. So here there is low pressure or normal pressure. Here there's still normal pressure, the normal amount of molecules. So the high pressure, the region of high pressure molecules is going to basically, it's going to try and move into the low pressure area. So all these molecules are going to rush into the normal pressure. Anyway, you can see that we're getting a pressure wave. But that's actually a pressure wave, and what we're looking for is a surface wave. It's a little bit different, but you can imagine pressure wave is a little bit different. But let's discuss a surface wave. But you can imagine a pressure wave advancing. But that's not how surface waves behave. Let's talk about surface waves. So you have water. Let's use this. So you have water level, and you drop a pebble in the water. So the pebble is now here. Let me think. Yeah. So the pebble is here. So this caused the water to move from here to here. And then the pebble falls down below, and the pebble is no longer going to be here. So this water, right, because there's a vacuum here, there's air here, the water wants to be flat. So this water is going to want to go back up. But as it goes back up, it's going to overshoot. This is so funny. It's going to actually overshoot because it's going to have, basically, you could say that this block of water was pressed down. Whoa, what's going on? Did you delete it?
I didn't do anything.
Okay, so it's bugs in the system. 1 second.
Bugs in the matrix. A ghost in the machine. Ghost in the show.
Is that from a movie?
Oh yeah, but it's also scientific as well.
Hmm. Anyway, so you could say that the pebble forced down a block of water, and then when the pebble is out of the picture because it fell down to to the bottom of the lake, then this box of water wants to rise back, but because it has momentum, because the pebble introduced energy into the system, and now this block of water is going to overshoot to above water level. And then it's going to bounce basically up and down, basically forever, you could say. And as it's bouncing up and down, when it's up, I actually don't know exactly how how surface waves are formed. But anyway,
Is it like a tug? Is it like a tug of war between the rock going down and the water trying to push up against it?
is it like a tug of war between? I mean, tug.
The
Anyway,
rock's trying to
I would
overpower
say
the water, and the water's trying to push back up.
the way I would say it is this block of water wants to go up and down forever. However, because it's water and we're talking about pressure, so when it's up here, it's creating a vacuum. Is it? Yeah, it's like creating a vacuum. When the water is all the way up here, it's creating a vacuum and it's causing the water to rush. The water change the color now to white. It could be. I mean, we would. I mean, I once actually researched exactly how water waves propagate, and it's actually super complicated. But I never researched how water waves, how you start a water wave by dropping a pebble into the surface of water. I never looked into it. It's probably a very, you- I mean, you need to really study. This is called fluid dynamics. So
Okay.
it's a whole thing. Let's add it to the list of topics that we're also discussing. Fluid dynamics. Fluid dynamics. And we can actually use there's actually a whole field in physics. It's called the navier stokes equations that we can use to predict exactly, to simulate, to create a simulation of uh, of any liquid. And I think we can, I'm pretty sure we can use navier stokes to predict or to run a simulation. Yeah, you cannot edit. I'm not editing the schedule. Okay, I just edited the content. Anyway, it's some complicated way, but you can tell that, or you can imagine that as the block goes up and down, every time it's up, there's a vacuum here, and water rushes in, maybe, and then when it goes down, you could say also there's a vacuum here. Water should rush. I don't know. I don't know. But what we can look. You know what we should do. We should go to. Let's create another guy. So let's talk about a rope. And this is an example. Let's do rope wave mechanics. Let's do rope wave mechanics. Wait, what did I do? Oh my god.
You cleared the screen.
What did I do?
Well, it seems like you've cleared the screen.
No,
Or
I
you've like
no, I created a new thing because I want to do.
different, oh,
Yeah,
different tab.
yeah. I want to do wave mechanics using a rope. Why can't I scroll?
No, no,
It's not
no.
letting me scroll sometimes. Do you know why?
Uh,
What did I
well,
miss?
click X. Click X. You have to like get rid of the pencil. Now you can scroll. You can't.
It's not. It's not reacting to.
What's
Oh, I need to. You need
go on,
to draw. No, no,
go on to the grey area.
no,
Why
no.
do you
I
need to
think.
scroll?
I think it's because I first needed to draw something in order for it to allow me to.
Oh, okay, okay.
Okay, give me a minute. I'm gonna run to the bathroom and come back. Okay. You know what? Maybe we can. Let me look up uh, rope wave mechanics. So everybody will see a video while I'm gone to hell and back. Let me
Oh,
just find a normal place. Here it is.
oh, hell is other people.
Oh,
Oh,
rope wave mechanics. How much time? 1 minute. Okay, it's pretty good. This is a demonstration. Maybe you will learn something from this demonstration. 1 second, we want this. Okay, so it's called what is it? What's the name of this thing? Oh, wave speed demo. That's good. So let's share wave speed demo. There you go. So I'm gonna play this and run and come back.
okay.
1 second.
What's supposed to be happening? Is anything supposed to be happening? But nothing is happening if you want something to happen. Wait, okay. 1 second. Like nothing is. Oh, I see. I see. How do I play this again? Play it on the YouTube. The power of love.
All right. Did you understand?
I'm trying to watch the video one more time,
Oh,
but
let me play it. Let me replay. It's too complicated. It's not what I want. I wanted something a little bit simpler. Let's see if we can find something just a bit simpler. Standing.
so
What?
as the rope has more tension, the wave is going to move faster. It's
Good.
going to be more aggressive,
Good.
and as there's less tension, the wave is going to move slower and less aggressive.
Good,
That's what I got.
good, good. But it's too. I don't need so much detail. I'm actually looking for the mechanics and less for such a complex. He he's not really explaining the mechanics. I wanna talk about the mechanics, how it happens. Let's see, wave equation derivation, wave frequency. But how does it work? Maybe because I wrote mechanics, it's not a good idea. Rope wave experiment. Let's do a rope wave experiment. Maybe we should watch a couple of videos about different waves, like ropes and slingies and stuff. Let's see what this guy is saying. Too complicated. Okay, let's try that again. What's this? Rope wave. That's pretty good. Oh, no words. Okay, that's good. So basically, what's important to see is this thing is just going up and down. Every piece of the rope is only moving up and down, but the wave is moving to the right. That's something very important to notice. Let's see one of the older, like there's a guy from really old, the old days. Wow, look at that. The wave is moving back
That's
and forth. Wow, that's incredible. And what's this? Wow, look at that. That's incredible.
what's
Okay.
that one? Oh.
What, did you see it? You didn't see it? This one.
No, oh, I watched that one, but I thought you was going on to another one.
Can you see what I'm showing?
Well, it's just a screen at the moment. There's nothing
Oh,
moving.
oh, I'm not sharing? Oh,
Yeah, you're on YouTube.
it's so terrible. Oh, I never showed. Oh, I never showed it. Oh,
Yeah, that's
I went, came back, and I thought everybody was watching. Oh my God, this is so terribly terrible. Wait, the problem is if I show you, yeah, it's horribly terrible. Okay, so you can see it. Oh, that's good. Okay, so you can see this. So let's look again for a rope experiment. Let me try and increase. Oh, that's good. So we can watch it this way. Let me see if they're explaining it. Nothing is moving? Why isn't
happening
nothing
first.
moving? No, you don't need
You
to.
could, why don't
It
send the
should
video?
play.
Oh, you don't want to?
Oh, wait, can you? Yeah, you can see me. Yeah, this one is not, nothing is happening. Even though it's moving forward, but it's a terrible explanation. So I wanted you to see this guy. Come on. Maybe I need to replay. Oh, I didn't want to do that. What's going on? Why is it? What is going on? Screw it. We'll do it live. Okay. So this one. Okay, now it's working. Very nice. This one. So when it gets to the end, it doesn't just start from the beginning? Why does it do that? Oh, here it is. It's starting from the beginning. Good. So what's important to see here is that if you follow the red dot, it only moves up and down, up and down. Every piece of the rope is moving up and down, whereas the wave is moving to the right. Like if you put a ball here, it would move to the right. Let's see this guy. What is this guy saying? 7 amazing science gadgets. I don't care. Um, Stationary waves. I don't care. This is kind of interesting. Is it gonna play? I don't know. Is it? I don't know what's wrong with it. Some of them play by themselves. Some of them don't. Okay, now it's playing. It's some bug. Check it out. Can you see it?
Yes, I can.
Okay. Let's
Oh,
see.
oh, do that again.
Oh, that amazing.
Yeah, that's weird and
Absolutely
interesting.
amazing. So this is, yeah. Okay, what is he? Slow moving waves in rope physics. How is he moving it so slow? How does that work? I don't know. Homemade signs. I don't know. Okay, here's the forks. He's hitting this fork. Okay, let's see this experiment with. A hertz just means once per second. So 260 hertz is 200 times per second. So it's vibrating back and forth 260 times per second. That's what it sounds like.
Wow.
This proves that it's moving back and forth.
Oh, yeah. Oh wow. Okay. Yeah, this is very interesting.
Yeah,
Okay.
for
Yeah,
sure.
very,
Wave,
very.
right. So this is wave mechanics. I don't know what that is. So it's different frequencies, 512 per second and 440. Now they're the same. Yep. Okay, so let's go back to the experiment. Let's see if there's other interesting rope experiments. Well, let's look in general for wave experiments. Any, I'll take any.
Slow motion rope waves.
Yeah, but let's take any wave experiment. So this should be interesting. Interference experiment. Come on, you can do it. There you go. So this is, it's called interference pattern. Like they're not explaining, so we'll skip it for now. What's this? This is the double slit experiment. We'll come back to this when we do quantum mechanics. This is the foundations of quantum mechanics. We'll come back to it. Let's see, sound wave experiment. It's kind of interesting. We'll come back to it. Oh, this guy's the best. But this is electromagnetic waves. Electromagnetic waves. That's where I'm heading. And this is, I've actually covered this video before. Okay, wave producing machine. Let's look at this. Okay, she's pressing the button. So all that's going on is that these rods are moving up and down. Each rod is only moving up and down. The rods are not moving sideways, but the wave is moving sideways. Okay, too much noise. Oh my god.
Hmm.
Okay, what's this? Oh, this is, but that's just fake. I want to see actual experiments. Let's see other things. I don't like simulations. I want to see actual experiments. My God, why is it so difficult? Oh, Slinky, that's good. Why do they have to make so much noise?
Mute it.
Now it's stuck. I don't know what's going on with my internet, or this never happens. What am I doing wrong? Fail,
Press pause and then play the video again.
pause, play. No, it gets stuck.
Oh, yeah.
I don't know. It's getting stuck. What's wrong with my internet? My internet should be okay.
It's okay now.
Okay. So maybe because I was the window wasn't focused. Forget it, idiots. I hate
Uh,
videos that they don't talk, don't explain anything.
Professor Dave explains. Lol.
Yeah. Let's see.
Do you like him? Do you like that guy, Professor
Yeah,
Dave
a
explains?
little bit. I mean, he believes like the norm. He's a normie. He believes in global warming and stuff. So
Do you believe in global warming?
no, no, it's utter nonsense. It's completely nonsensical. But we're not allowed to say that because they'll take us off of YouTube. So let's ignore that. Let's
Do
see.
you believe in flat Earth?
No, no, I'm not a flat earther.
What other scientific consensus do you disagree with?
Most of them, by far most of
Like what? Like what's the most controversial?
the most. I don't know. Like most scientific consensus, I disagree with. Even you see, I had a conversation with someone yesterday. I derived general relativity from Newtonian gravitation, and no one. And the guy kept telling me how every step of my math is wrong, even though I'm doing very, very advanced math techniques and I'm getting the perfect right answer. He knows the answer is correct for the event horizon of the black hole. So I'm getting it right. I'm doing many, many mistakes according to him. I'm dividing by zero. I'm making every mistake possible, but at the end, my answer is correct. Really, really. So yeah, I mean everything. Much of what I say is very controversial, but I think that most scientists, I would say, disagree with each other on everything. Like if you watch YouTube about special relativity, special relativity explained. They're all going to
Uh-huh.
disagree with each other. They're all going to tell you there's going to be YouTube videos why the rest of the YouTube videos are wrong. Let me see.
Yeah, yeah, yeah.
And special relativity at this point is over 100 years old. It's from 1905. There's a video that I watched. I think Science Click. He made a video. He reviewed everyone else and he showed why everyone else is wrong. And then everyone else made a video to show why he's wrong. So everyone disagrees with everyone over everything. So there's no point. Like if you think if you find that you disagree with the consensus, then you're actually part of the consensus. The consensus, like Einstein disagreed with everyone else over quantum mechanics. There was a famous war. There was a war called the Black Hole Wars about the nature of black holes. Let me just find the special relativity war. Let me find that video with the special relativity war. Of course, when I need the video, no, I will not find it. It's just gone. It's erased off the internet because I need to show it. You know the rule. When you need the video, it's gone. It's the Heisenberg video. It's gone when you're looking. It shows up when you're not looking. It's basically a woman. Like when you don't need them, they show up. When you need them, they're like poof. Nope, they don't exist.
Uh,
The Heisenberg women.
yes.
Maybe everybody's wrong about relativity. Maybe everybody's wrong about special relativity. Maybe. And just let's look for wrong special relativity. How people
There's
get
a video.
here.
The
Look,
speed of light is not.
just look at this. This guy's big. Fermi Lab is a big channel. This is like mainstream. This is government. So relativity, how people get time dilation wrong. Um, okay, so this is a response to Dr. Lincoln. This is Dr. Lincoln from Fermi Lab. he's mainstream, as mainstream as you want. Dr. Don Lincoln. So here is a video. Dr. Lincoln is wrong about the twin paradox. So everyone disagrees with everyone all the time about the fundamentals. Special relativity is like nothing. It's one lecture in
Yeah, it's like all of the humanities, sociology, philosophy, they all disagree with each other. Like, there's no like,
yeah.
oh, everybody agrees with this. It's unanimous. Like, it's all,
I don't think there's
you can't trust it.
even if you talk to me, compared to me from a week ago, from a day ago, you would get different answers. Me from a day ago, I'm like a different person because today I was thinking about how GR gives you quantum mechanics, and and it completely changed how I feel about GR and special and SR. GR is general relativity and SR is special relativity because it's difficult to say. So every day, my whole universe gets upheavaled. Literally every day that I work on a problem, it gets upheavaled. Like the only time a problem doesn't get upheavaled is when you do the actual. You sit and you do the math, and it takes you a whole day. So during that day, you didn't learn anything. You just did math. But when you just sit and think, everything gets upheavaled. Everything. Um, the real
Even when you do the math, though, it's still gonna get upheaval.
Yeah, like yeah, you could say that too. Like when you do the math, you get you it's another layer of depth that you figure out. Uh oh
That's why does truth even exist? Like, that's why.
no. Okay, so she wrote a book why everybody's wrong about science, and she's like a huge like about strings theory. She left her field of string theory and physics. She basically left it because she just got so fed up. She has a chapter why she left basically academia, and she became a YouTuber. um
Can't quite go up, go up, go up. Can't quite be right.
right,
Can't
how we
be
know
quite
that
right.
Einstein's general relativity can't be quite right, which I completely disagree with. I
Is she
complete
just saying that is she just saying that it's not like completely accurate? It's
it's
kind of like approximately
it's
it's
not.
approximately true.
No, no, yeah, but it's because she claims there is an infinity both at the center of the black hole and at the event horizon. And today we already know there is no uh,
See, induction, how induction helped Einstein discover relativity.
how induction
Science
helped
uses it.
Einstein discover
Science,
relativity. Okay,
science is based on induction.
this guy is awesome. He actually teaches special relativity. He's a special relativity professor or grad student. I don't know.
Mm.
He's like amazing at special relativity. And he made the video why Dr. Don Lincoln is wrong. So he teaches this guy. So this guy he teaches special. He's a special relativity teacher, professor, and he disagrees with Dr. Lincoln, Don Lincoln, who is I guess like one of the managers, a big shot at Fermilab. That's like big research facility. This guy's not a joke. Like I've listened to him. He knows his stuff. He knows his stuff much better than I know my stuff. At least in some fields of course. And I would say in most of physics, he runs circles around me. And this guy runs circles around me in most physics. And some like I have my specialty, but and they disagree with each other. So that's and this is on fundamentals, on the twin paradox. How can you disagree on the twin paradox? Like it's like the most fundamental
I
thing.
think I think science is not literally true. It's morely approximately truthful.
Well,
So it's
science is precisely what you define science to be. You see me defining what science is for myself. You need to define science for yourself. Science is exactly what you want it to be. Science is basically a tool by which to live your life.
It's a religion.
It's whatever you want it to be. It's yours. It's a when
It's a
you
religion.
well, according to Popper, who is I would say the biggest
Oh yeah,
philosopher.
I know this. I know this guy.
So
Go ahead.
Popper said you classify science under mythology. Science is a
Uh-huh.
mythology.
Uh-huh.
It's categorized as a mythology. The day I heard that, I said, finally, I know what science is. Science is a mythology. I completely agree with Karl Popper about that.
But
But
don't you agree that a lot of people who are hardcore into science but don't want to admit that they are as faithful and religious as people who believe in God.
I agree. It's
Like
they don't
many
look
atheists are just irrational and they're not no better than the people who believe in God.
right. So I find it, yeah, extremely. I don't want to know. I don't know if I would say cringe, but someone who is. I used to be very religious, and today I'm very atheistic. But I think even when I was very religious, I was still open-minded, and I don't think I ever said that, like, I know God exists. I don't believe God exists. I know. I don't think I ever said that idiotic line that religious people say. And then you have the atheists who might say that atheism is not a belief. Atheism is, I don't know what, it's a non-believer. People look. It's just words. It's whatever you want it to be. But yeah, people are dummy dum dums. I was a dummy dum dum
Yeah.
yesterday. Today, I'm a little bit less of a dummy dum dum. Hopefully, when I die, I'm going to be even less of a dummy dum dum. That's
The truth is nobody knows anything.
I don't know if I would say nobody knows anything, but we try to know. We try to be a little bit less dumb than yesterday. That's what I try to be. And less dumb means I just want to know.
That's religion.
That's religion. Fine, religion. I
Uh-huh.
classify science as religion. It doesn't matter. It doesn't matter how I
Yeah.
classify what.
A lot of people get triggered that science is a religion,
Yeah, they're idiots.
especially atheists.
Yeah, they're idiots.
Yeah.
They
I didn't affirm that, but sure, go
No,
ahead.
they don't understand what science is, and it's very bad. It's very bad. They don't understand the limitations of science. And the same goes for math. It's not like math is better than science. I categorize math as a science. I categorize logic as a science. And science is a religion, it's a mythology. So logic is a
Math.
mythology.
How is math a science? What
Tell,
do you mean?
okay, let's start with logic. Logic would be simpler. So tell me, right? Logic
Uh-uh.
is about true statements, something like that. So tell me a statement.
Okay.
Tell me a statement that is true.
That is true.
Yes.
Uh, all things are identical to themselves.
Oh my God, that's a hard one. Why can't you say that the sky is blue or something?
Oh, okay. Good. Okay.
I can do both.
Okay. Well,
I can.
I don't.
Just
I don't. Okay.
just to
Do
let you
both.
know, I could do both, but it's gonna be easier with the sky is blue than all things are identical to themselves. But let's start with the sky is blue. Would you say the sky is blue is a true statement?
No.
Okay, then
No. I'm being serious. I don't think it's true.
I agree. I happen to agree because okay, give me another example of a true statement besides all things are equal to themselves.
Something is so like something either is or it isn't. It can't it can't be itself and not itself at the same time. Like a ball can't be completely blue and completely red at the same time.
Hmm.
Is that different?
Hmm.
Like imagine if I was a human, completely a human, and also completely a reptile at the same time.
Wait, hold on. Let's start with blue and not blue.
Okay.
So that's incorrect.
So
That is
all,
absolutely
it's all
incorrect.
over. It's all over red, and it's simultaneously all over blue.
No, that's absolutely incorrect. Absolutely
Okay, I'm going.
incorrect. There's no question about your
Oh,
statement is incorrect.
explain, explain,
Wait,
explain.
repeat the statement so we make sure that we get it right. Repeat the statement.
Okay. Well, what I'm trying to say is that something can't be uh it can't be itself and not itself at the same time. So the example I gave was a ball cannot be completely so all over blue
Okay.
while
Okay, yeah.
simultaneously being
No,
all over red.
no. I mean, the blue is easy. The example is easy. So you know what? Let's start from the okay. An object. Say about the blue. What?
It can't be all over, so totally or completely blue.
No. Okay, an object cannot be blue. Whatever. Yeah.
No. No. You have to have the nuance. It's not just blue. It's
Okay.
completely blue. So there's
Okay.
not a speck
Well,
of.
we know because of the incompleteness theorem, nothing can be completely anything. But fine, an object cannot be completely blue. Yeah.
While simultaneously being completely red or completely not blue.
Okay. Absolutely incorrect. 100%.
Okay, okay, go ahead, go ahead. Okay.
Right? You're gonna be surprised, right? It's gonna surprise you.
Yeah,
So, have
yeah,
you ever heard
yeah.
of the term blue shift?
No. Oh, is that like when an object moves at the speed of light or really fast, it's going to change color or something like that? It's going to like change
Yes.
in some way.
Yes.
Yeah. Okay. Cool.
So when something is moving with respect to you, wait, what is going? Why is there? Well, let me check 1 second. With
I'm very skeptical that what you're saying will, you know, be like
oh, it says
it's
the
going to
stream.
prove what I
Listen to
said.
this. The stream currently has reduced video or audio quality. This may be due to network conditions. Is this true?
Wait, what? I didn't follow. Sorry,
Uh,
I didn't follow what you said.
wait, why did the stream stop? It says your stream is still running. We've paused this preview. Ugh, again with the pause this preview.
Are you asking if the live stream has stopped
No. The
playing?
live stream. No, I'm talking about the actual the YouTube. See, it stops when I.
Yeah. One sec, one sec.
You see, it says
Uh,
the stream
oh,
stopped. It's fine.
oh crap! Yeah.
Yeah, I don't know why they do it. It's like
Wait. No, it's still playing. It's still playing.
no. The
Hello?
YouTube. I'm showing YouTube. You see, it's not showing the YouTube any longer, right? Is it?
Yeah, it's still. Yeah, it's still playing.
The you can you see the you my can you see my YouTube?
Still,
Let
yeah,
me
it's
see.
still playing. Yeah,
No,
look.
it says
See
your
the
stream.
echo.
No,
Hello.
but it says your stream is still running. You see the message. Your stream is still running.
Yes, sorry. See, yeah, I see this on the YouTube. I see it on YouTube. Yeah.
You see,
You just have to go. You just have to go on to Discord and change the screen, which is change what's on your home screen.
what do you mean?
Well, okay. What are you trying to accomplish? Like,
Look, when I switch my focus to a different window, to the YouTube video, to the YouTube tab, then
okay,
the message shows up. When I come back, then the message disappears. but I need to go away to play the video. I can't play the video from here. I can't play the video when I'm in Discord. I need to go to the other tab to play. The problem is that I'm streaming this tab. I'm streaming my entire Discord. So every time I switch away, and I don't know how to tell. I don't know who to tell to stop. Like they're saying we've paused this preview to save your resources. Don't save my resources. I'm trying to stream. They're saving my resources for what? Do you understand?
Not really. I'm so
No.
sorry.
You don't see the message.
Go on.
Your stream is still running.
Yeah, I see this. Yeah.
Okay, I cannot. But right now I'm playing. I'm playing a YouTube video.
Oh.
Here, let me
Okay.
go back and show you. This is what I'm playing. So I'm gonna play it and go here. It's gonna play. But if I
No,
go
no, no, no,
away,
no, 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 no. There's just a lag behind.
no. When I go away, it says your stream is still running. It stops streaming it. Every time I switch to the YouTube video, it stops streaming the YouTube video. The YouTube video keeps playing in the other tab, but the Discord stops streaming. It stops streaming to Discord.
I'm so lost, but I'm so sorry. Is it like the end of the
It's
world,
very
bro?
confusing. It's very confusing because
Yeah,
you've never streamed. You don't know the issues that
yeah.
arise when you stream. It's like normal things that work normally do not work normally once you stream. Everything gets upheavaled because they don't care about streamers. Why should they care about streamers? Like there's only very few of us in the universe, so they screw us. They just don't. But before I was able to play while you were watching. So how can I do that again? That's what I would like to do.
It's just
Tab,
it's
this.
it's a spooky action at a distance.
How do you know that term?
Oh, there's this YouTuber called Inspiring Philosophy who tries to incorporate science and physics and quantum physics to prove that God exists.
Oh my God, Jesus help me.
Yeah, I
Jesus.
mean, his videos are extremely compelling and convincing, but that's probably if you don't know too much about physics.
No, I mean
Well,
you.
I didn't know too much about physics, and I was like very, I wouldn't say convinced, but it is convincing what you were saying.
Yeah, I mean, if you don't know how to science, then people can fool you. That's
We
why. That's
we
why.
should react to one of his videos.
Yeah, we should. We should react to many people. Everybody's wrong on the internet, so we should react to everybody while we're at it. react to. Let's make one YouTube video. Everybody's wrong on the internet. Let's react. Everybody is going to be like this. Hey, everybody, you're wrong about everything. Have a great rest of your day. Or also, stop streaming because you're all wrong. Stop spreading disinformation. And then the government says you're spreading disinformation. It's like everybody
But
disagrees
proper
with everybody. What?
this information, otherwise known as propaganda, is content.
Whatever. But the government says, "Oh, you're spreading
It's
disinformation." It's
true.
like
It's true.
but
You
it's like
make money from
yeah, but
you
it's
make
like
money from the wrong information.
that's true also. But I'm saying everybody disagrees literally with everybody else on the planet about literally everything. So what exactly is
Uh-huh.
disinformation? What is that nonsense? I mean, the government has one voice. That's not even true. Even Fauci, like during his tenure, he kept changing his mind. In the beginning, he said it's just a cold, don't worry about it. And then he started saying you have to wear a double mask, and then he was in the stadium. Oh, I was wearing a mask, and then he was in the stadium
No,
without
no,
a mask.
no.
Oh, you don't have to wear a mask.
But I really want to see your disproof of what I said about the object being blue and red
Oh, that's
completely
that's too
both ways.
easy. Yeah, are you kidding me?
No, it's not. No, it's not. It's the law of non-contradiction. This has been. discussed for many years, and
Okay.
nobody's
What makes you
nobody's.
what's your evidence? What's your evidence that there is a law of non-contradiction?
Oh my god. Uh,
Have you gone down the
okay.
Wait, have you let me ask you. Did you go down the street one day and you met the law of non-contradiction?
No, no, no.
Then
The
how do
law
you
of
know it's true?
non-contradiction.
How do you know it's true?
Okay. So I think the idea is that it's inconceivable
Wait
to
a minute.
even.
What do you
You
wait,
see,
wait, no, no, no. What do you mean you think? You're basing everything on a law that you think?
what do you mean?
Like it has to be it's a you have to be 100% sure. But now you tell me that you think, fine. So how do you know the law of contradiction is true? Maybe it's false.
Yeah, that's possible. Sure, maybe it's
So
false. Yeah,
yeah, so why are you deriving anything from it, assuming it's true?
because I've never seen a contradiction
That
before.
doesn't mean anything. That's literally
Yes, it does.
no, it doesn't. So
It
what?
means it has inductive support. It means it has inductive
Yeah, but
support. If I,
induction is not true. Induction is just induction. And here's the kicker:
what does that mean? Induction is just induction.
who
What does
says
that mean?
induction is true?
We act as if it's true all the time.
Wait, what?
We act as if the law is true all the time.
I didn't say
Principle
we
of induction.
don't. I didn't say we don't.
Yeah, so
But who
so
says
it
it's
seems like it's
true?
in this.
That's not evidence.
No,
The
no, no.
fact.
Okay, okay. Look. If we're acting like it's true, it seems like it's necessary for us to live our life.
So
So it seems the best explanation for this is that it is true.
no. I mean,
Yeah. Well, try living your life without using the induction law.
okay. I do. I mean, I don't even
Uh,
know. I don't live my life by that law. So as far as I'm concerned,
Yes, you do.
really,
Yes, you do.
really,
You do.
how do I live my?
Yes.
I never heard of this law.
Let me just explain what it is then. So it's that uh stuff happening in the past. If something like if
No, no,
there's
it's
like a
okay.
pattern
No, no.
of
Look, that's not the point. I agree with the law. I agree that a thing, if it's one thing, it's not the other. Like if you say one plus one is two, then you can't also say
yeah
one plus one is not two. You can't. A
yeah
true state.
yeah that's the
Right. So, but who? That's fine. The fact that I agree doesn't mean that it's true. It just means I agree. What's the definition of true? How do you know it's true?
well, there's different definitions of truth. Sometimes it's true because it corresponds to reality. Sometimes it's true because you can make predictions
No,
with it.
no, no. Okay,
Let's
okay.
pick a definition of
Okay, then maybe we don't disagree. Fine. So, what's the definition of truth?
let's pick a definition. Let's make a
Fine.
definition of
Let's.
truth.
Yeah, I don't have a problem. Go ahead.
Uh, Truth is just that which is useful.
I don't know what that means.
Well, if it's not useful, then
How is
we wouldn't.
how is gr useful? How is
How is
SR
what?
useful? We're never going to use GR,
Yes,
SR.
I don't know what a GR or SR is.
The GR is general relativity, SR is special relativity. Why should I care if we can derive general relativity from Galileo or from Newton or from Einstein? How useful is that? That's
Because
like so useless.
it helps us make predictions about other things in reality.
What does it matter? General relativity.
You could because if it helps us make predictions, then it means that we
How
can
does it
avoid
help me
making.
make prediction if I can derive it from Galileo or from Newton? We know GR is true. Why is it important where we derive it from? All I'm saying is historically Newton could have derived it. Galileo could have derived it. But
I think you're muddying the waters.
no, that's muddying the water is something else. Muddying the water means no, no, no. I'm not muddying. I'm going
I think you're
directly.
changing the subject. I think you're
No,
changing the subject.
no, 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 no. I mean, I'm contending your definition of truth. Usefulness, like if the truth is that I killed someone and therefore I need to be executed, then the
What?
truth is not useful. If the truth is that I
I
need
don't understand.
if the truth
Therefore, you need to be executed is not something we would say is true or false.
no, but let's say, but you're saying you're assigning usefulness to the truth.
No, 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 no. Okay. No, no, no. If you killed somebody, that's we can say it's true. And why is it true? Because it's useful. Why is it useful? Well, now we know to keep my children and my family away from you so they do not get
But it's
killed.
not good for me. If you're gonna execute me, it's not useful for me. So how could you say it's true?
Because it's Darwinian, so it's we
No,
use
it's not
evolution.
good for
So,
me. It's not good for me. So
so
it's
what?
not useful for me. How could you say the truth is useful? The truth is not useful. Sometimes the truth is.
Why does why does usefulness, utility, have to be all encompassing? Why does it have to help every single body on the world?
So I don't.
In the
Okay,
world
let's then explain. You said if it true is what is useful. So useful to whom?
to evolve for the human species. Isn't that how genes work? They're selfish. They want to reproduce.
So truth is what helps the gene. How do you know what helps the gene? What helps the gene? What if aliens come here and they say, "Oh, you eat meat. Oh, then we need to execute you all." So is then the fact that the truth is that we eat animals, is that useful? We're gonna end the gene.
Like, let's slow down then. Okay, so I just need to understand what you're saying. So your response is that so you're contending that truth is that which is useful, and the example you gave is what it's a hypothetical. What if aliens came to Earth and said we need to kill you all, and I'm not following that part.
If you eat animals, if it's true that you ate an animal, then we need to kill you all. We need to end your gene if you ate an animal. They say to the human race. Well, the truth is that the human race has ate an animal. Actually, they ate many animals. And if you tell this to the aliens, they're gonna smack you and kill you, and no more gene for
So
humanity. So is
if
that
the aliens came to Earth and said, if it is true that you ate animals, then we need to kill you.
yes?
Well, that's an argument, and arguments cannot be true or false. They can either be good or bad. Only statements, singular statements, can be true or false. No, I can make an argument that's not true or false. It's just good or bad. Something which can be true or false is the cat is on the mat. You killed somebody. I ate a hamburger. I like you, like that sort of thing.
Then I'm completely lost. I don't understand.
How can an argument be true or false? If I say this is an argument,
You said
uh,
useful. I'm showing you a hypothetical where the truth is anti-useful, and then you're telling me
how
the truth is that we ate an animal, we need to be killed. So the truth
okay,
is that we need to be killed.
no,
That's not useful. We better.
no, no. Oh my god,
The answer is you better lie and don't tell anyone that we've been eating animals. Tell the universe
no,
we're
no.
we're vegans.
The sentence is a conditional statement. It
You
says
agree?
if this is
You
the case,
agree? You agree that in such a case we should lie. We shouldn't tell the truth, right?
we shouldn't say that we ate an animal.
Of course. That is useful.
Why?
So lying is useful. It's not true that truth is useful. Lying is useful.
This is going over my head. Conditional statements are not true or false. If I say if it's the case that this is the case, then this other thing will be the case. That's not something which can be true or false.
What are you
Like
talking about?
that's a category. You're saying if it is true that you ate an animal, then we must kill you. That sentence is not true or
I'm not
false.
saying that sentence is true or false. I'm now asking is the truth that we ate animals, is that, I mean, is that, is it useful? Is the truth useful, or is it not, or is it
Yes,
anti-useful?
it is useful if you ate an animal.
The truth is useful.
Yes, the truth that you ate an animal is useful.
What what if I don't, I'm not, I don't understand. I don't understand how you're saying the truth is useful.
Uh-huh.
The truth is what
If
is
I know that,
so one.
if I know that, if I know that you ate an animal,
Wait,
I
it's,
can make
wait a second.
a
It,
lot.
okay, so it's useful to humanity.
Yes,
So and as, like for aliens, truth is useful for them.
yes.
So
They
truth.
can
So
make predictions.
so that you can make
They can make predictions
they can make a
about it.
so
They can make.
you can create a contradiction. So to them, one plus one is three. To us, one plus one is two, and both are true.
Wait, what? I don't get it. If they say that 1 + 1 is 3, is that true? What?
Okay, so you're saying they would agree that one plus one is two.
How is that relevant?
No, no, I'm trying to see how your definition of truth is useful for the human race, right? Is that what you for the gene?
Yeah, it's useful for the genes to
How do you know? How do you
reproduce.
know what is useful for the for? What do you mean for the genes? There's many humans. Genes.
Yeah.
Whose genes? What if I cannot reproduce? What
Oh my god.
what do you mean? I don't understand. Your definition is so like biological. It's like who I never heard of such a definition that the truth is what is good for the genes. You know, do you know how many genes you have in your in your body in each cell?
Yeah. Well,
How
not in
many?
each cell, but I know. I
How
know.
many
No, I
genes?
said. No, no, no. You're mishearing. I said I don't know how much in each cell, but I know that it is a lot.
That it's what?
A lot.
No, there's like 23. That's why it's called
Yeah.
23 and me. There's 23 genes. Each one is but all humans have different genes. The genes are completely different. I don't understand.
Okay.
So whose genes? Who,
Okay.
the truth is good for, like for the reproduction of the genes. Like
Yes.
whose genes?
Anybody.
What do you mean anybody? The
If you're talking
dinosaurs too? What do you mean anybody? Define
the
anybody.
dinosaurs.
What?
Well, I'm talking about human beings.
What?
Human beings.
Define human beings.
Define human beings.
Hmm.
Some somebody who's a member of the Homo sapien race.
Yeah, define.
Homo sapien.
I'm gonna ask you to define endlessly now. You're not gonna be able to do it.
Yeah, I got that. Yeah, sure.
Define human being. Define Homo sapiens.
Yeah, but this is going to be an infinite regress of define this, define this, define this. But
Yeah,
you're just
yeah, yeah.
moving away from that. Yeah, but you're moving away from the actual point and
No,
not proving
no, no,
anything.
no. Actually, this is the incomplete. This is the that's literally the incompleteness theorem. That's literally incompleteness. You see that your truth is incomplete. That's actually perfect. That's a perfect ending point. That's literally
How?
the incompleteness theorem.
How? So the incompleteness theorem says you can't prove it in the system.
Right. The system has to
Yeah,
depend on axioms.
it
So
doesn't mean it's not true though.
what?
It doesn't mean it's not true because the incompleteness theorem Gödel says that something can be true, but you can't prove it in the system.
No. Ignore girdles.
Yeah.
No, no,
It
ignore.
does.
I didn't say. No,
Yeah.
no, I never say girdle. Forget about.
Oh, okay. My bad. My bad.
Yeah, he's an idiot. If he said that, he's an idiot. Ignore him. Do you know why he's an idiot? No, of course it's wrong.
I don't.
You just quoted
I
something that is
disagree.
obviously wrong.
No, it's proven.
And
This
you
is
can't.
stood the test of time.
No, no.
Nobody can disprove it.
Are you kidding? It's so obviously wrong. It's complete nonsense. Forget about girdle. If you want,
Appealing to
okay.
appealing to what's obvious is not a good
I'm not.
argument.
I'm not going to appeal to what's obvious. Of course, we're going to prove it, but of course, the proof is going to be incomplete because of my incompleteness theorem. Forget about girdle. Obviously, he doesn't know what he's talking about. Obviously, to me,
Excuse me. Okay.
we're not going to appeal to authority. We don't respect anyone, only ourselves.
No, 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 no. That's the name of the mathematical problem. It's
Hmm.
Gödel's incompleteness theorem.
Yeah.
So I'm not appealing to authority.
No, no.
I'm just telling you what the name of it is.
I know.
And
I know.
this principle has stood the test of time, and no mathematician has ever been able to prove it wrong.
Yeah,
It's
but you
literally
know.
the consensus.
Yeah, but you know
And
me.
you're saying it's obviously wrong.
Yeah, you know me. You know that I
Okay.
disagree with everyone about everything. So that
Yeah.
shouldn't surprise you.
Well, you win a Nobel Prize and disprove
I'm
his
not.
theory.
I'm not going to dox myself to get a Nobel Prize.
Okay, well, uh, email me the proof, and I'll win the Nobel Prize for
You're
you.
not gonna get a Nobel Prize. They're gonna spit at you. You think
I
you're
would
not
win a
gonna?
Nobel
You're
Prize if
not
I
part.
disproved
You're
Gödel's
not.
theory.
You're not
I'll
part.
be a billionaire,
You're
bro.
not in the club. You're not gonna be respected. They don't care for you. Forget it. You're not in the club. You're not a member. You can say that they're all wrong and prove it 100 times until you turn blue in the face. They don't care. It's a club. It's nothing to do with anything. It's just a club. Okay, let's continue. The incompleteness theorem. My
Okay.
incompleteness
Which one?
theorem.
Go ahead. Go ahead.
So the incompleteness theorem, we just got there. You saw it. You saw my incompleteness theorem. You don't need anything. Anything you say is an is an causes an immediate infinite regress, because every word you say I can forever ask you to define it, and you're always going to enter into into circles, into because
Yeah.
language. What?
This isn't unique or new. There's a guy called Jacques Derrida. I'm not. I'm sorry. I'm not appealing to authority. This is just like a reference. If someone watching this wants to Google this and research more, so he's saying that words mean something. Let's say triangle. A triangle means a three-sided polygon. But then you can immediately ask, what does three mean? What does sided mean? What does polygon mean? You
Hmm.
define each of these, and then you're gonna go on the trail again. You're gonna be asking, what's the definition for these terms, these terms, these terms, and the original definition for the word is always going to be deferred and always going to be pushed back. So you're never gonna define the actual word you was trying to do. Yeah, I agree. Like I don't see how that's relevant though. It's kind of
That's
like uh, it's kind of like, sure, we have to have epistemic humility. We have to realize there's a lot of problems we can't actually fix, but we have to get around it so that we can live our lives. So we have to kind of shelve it or bracket it and get to the interesting stuff, basically.
hmm and until then, you cannot declare that something is true. If you do that, you're lying. You can say it's been shelved. We don't know. It seems true. We act as if it's true. We're fine with it. But is it true? We we don't know. We don't know if it's true. We don't know if it's false. Not in the absolute sense. It's or
Yeah.
you
Okay.
could say, look, based on this axiom, you start with some axiom that is not true.
Huh.
To say that the axiom is true is a lie. An axiom is not true. You start from axioms and you assume they're true, or you act as if they're true.
Yeah.
And you
Yeah. Yeah.
explicitly say, listen, we didn't prove it, we're not going to prove it. This entire system is going to be founded, this is going to be the ground truth of this system. We're going to act as if it's true. Is it true? That's undefined. Axioms are not
Okay.
defined as true or false. To say that an axiom is true is incorrect. And to say that it's true but we cannot prove it, that's idiotic. If you cannot prove it, then it's not true. Then it's true and false are not applied to axioms. You start from an axiom, then you use the rules of logic, which by themselves are not true or false. Again, the rules of logic themselves are axiomatic, are axioms. You act as if they're true. Are they true? Undefined. Gödel said they're true. He can go jump in the lake and take everybody else with him. I don't care. I don't care. Derrida or whatever. Who said? Who's the other guy? Derrida.
Yeah, Derrida. Yeah.
Derrida was in the right direction, but if Derrida didn't take it to mean incompleteness, then he missed the boat. He can go
No, yeah, he did. He did.
what?
Yeah, he did take it to mean incompleteness. Yeah.
By the way, your audio is cutting in and out. Do you know why? It's like
Oh, mm, well, you can't hear me.
it's a. I can hear you perfectly, but it's like it's jittering. Do you know what jitter? Like it's sometimes like just once in a while, every other word is like a tiny. Wait, what's going on? Okay,
Hello, am I?
am I? You just said am I?
Am I better? Can you hear me better now?
I don't know because you just said am I and then you cut off. So what happens, I think, is
Yeah.
maybe you speak quietly and the sensitivity, right? The microphone has a sensitivity, and in Discord, they don't record everything, all the noises. To cut out the noises, they only go from a certain level of noise and above. So you got to speak loud to the mic in order for the mic pick up everything. Maybe that's the problem. So try speaking more loud.
Oh well,
Mhm.
am I better able to be heard now?
You were heard perfectly before. It's just that you were cutting. I think it's because you were speaking too not loudly enough. All right. So,
Oh, okay.
do you understand my incompleteness theorem?
I do, but I I would respond and saying sure, absolute truth. That's probably not in our reach, given all
What's
of
the
our
difference? Hold on. What's the difference between absolute truth and truth? Let's maybe we agree.
but,
Just let's define.
no,
Maybe we
cap,
agree.
cap, let's say absolute truth is capital T
No,
truth.
no, no,
It's
no.
like
Let's define. No, no, no. Define it.
okay. It's how things actually are.
What is actually? What does it mean
The
actually?
reality.
What is reality?
It's how things are.
You said that. What is are?
Yeah.
How do you know what things are?
How
How
do
do you
how
know?
how do I know? Oh, well, I don't know anything.
Good. Good start.
Yeah.
But what do you know?
Yeah. Nothing. I only know that I know nothing.
No. No. You know, right? You experience this universe. You know that you experience this universe. That you know.
No,
You don't know.
I think therefore.
No. I don't like I think therefore I am. That's a definition.
What you were saying that just seems to me the same thing. But I was gonna say, I don't know that I am experiencing anything, so I actually disagree what you just said. Actually,
That's fine. That's fine. You can say
yeah,
that you don't know that you're experiencing. That's fine. That's good. But
yeah,
but you can define that my experience, that's all I have. All I have is my experience. Whether I exist, I don't exist, whether things are as I see them, or they're completely different, or who knows what. I don't know. But all I have is my experience. That's all I have. I have my experience. I have my notions of truth and false and and logic. These are all my feelings. I feel something is true. So, what is objective
I
reality? Go ahead. Go ahead.
just like mind, like it's just mind independent. It's just a mind independent world.
Just the opposite. I don't know any. I
What
cannot.
reality?
Right. But mind independent means the world without my mind. And I am not aware, right? By definition, the world that I'm unaware of. So the mind independent universe is unknowable to me by definition. So, objective knowledge, by definition, is always and forever unknowable to me. By definition, if aliens come 1,000 billion trillion years from now, the most advanced aliens, and they tell you, we have achieved objective knowledge, you know they are mathematically, with mathematical certainty, you know they're lying. It's unachievable. It's unknowable.
Unknowable.
Yes.
What is knowledge? What is knowledge? Can we like let's say when we say we know something, I know that the Earth is not flat.
Hmm.
Uh, it seems like there's certain things I'm saying. It seems like I'm believing something.
No,
It seems like
I would say that it seems like the Earth is not flat. To certain people, maybe it seems like the Earth is flat. I don't really believe them. I've spoken to them. Maybe their brains are broken.
no.
Go ahead.
When I when I say I know that the Earth is a globe, or it's not flat. Let's just keep it simple.
Sure.
It seems like what I'm saying when I say I know. It seems like in order for me to say that, I'm also saying that I believe that the Earth is not flat.
Correct.
It, it seems like I'm also saying that I am justified or I have reasons or justifications for believing that.
Yes, I agree.
Uh, it was. It's also seems like I'm saying that what I'm saying is true, or it's
Yes.
true to me as
Yes.
far as what I know.
Yes.
So it seems like these three things: justification, truth, and belief, are three necessary things. Like it's what we're getting at when we say I know X.
Wait, wait. Hold on. I have a call. Let me just
Uh-uh.
text. But I agree with everything you're saying. Hold on. What is that? 1 second.